On this problem, we're looking for two different numbers. So we know that we are looking for one number that we might call x. And I am going to just call that the smaller number. And then I'll call y the larger number. And so now we can make a system of equations using our variables. First off, it says that the sum of the numbers is 66. Then it says the larger number is 10 more than the smaller number. Now I have a system of equations that I can solve. If I do substitution, since one variable is already isolated, I could plug x plus 10 in for y. This would yield x plus 10 equals 66. So the smaller number is 28. I know that 28 is the smaller number because it's equal to x, and x is the smaller number. So what about the larger number? Well, we know that with x equal to 28, we have 28 plus y equals 66. And therefore, y equals 38. And you'll notice that those two numbers satisfy the conditions that were placed. They add up to 66, and one of them is bigger than the other by 10. On this one, since we are looking for how long the workouts are, I will say that x is workout time for plan A, and y is workout time for plan B. On word problems, it really helps if you define your variables right off the bat so that you know what you're working with and what everything stands for. So the amount of time that is spent on Monday was 3 clients at X hours each, plus another 5 clients at Y hours each, for a total of 6 hours. And on Tuesday, I get this. Now I have a system of equations that I can solve. This time I will do the elimination method because I see that I can multiply the first equation by -3, simple dimple, and get this. When I add the equations together, I get this. Solving for y, we get 3/4 of an hour. So y, which is the workout time for plan B, is 45 minutes, 3/4 of an hour. So what would be the workout time for plan A? Well, we need to figure out what x is. So I'll just take that first equation and replace y with 3/4. And so I get 3/4 of an hour there as well. So plan A and plan B are all 45 minutes per person. And that's how long the sessions are. On this one, we are looking for how much each type of box weighs. So that lets us know what our variable should stand for. X equals weight of small box, and y is weight of large box. And of course, I could have done it vice versa, switching the x and y. It would not have mattered. So it's time to start building equations. We see that the combined weight of a large box and a small box is 55 pounds. So I get this. Very similar to the first problem that I did on this video. Then we see that the total weight is now what is being discussed. So the total weight of small boxes would be the weight of one small box times how many small boxes there are. And then we would want to do the total weight of large boxes. And all of that weight put together would be 3,250. We now have a system of equations. I could do elimination, but I would need to multiply the first equation by either -70 or -55, which is fine. But then the numbers get really big. Well, what the heck? Let's do it. Let's multiply that first equation by -70 because I am living dangerously. Now, when I add the equations, I get and dividing, I obtain 40 for y. So the weight of y, the large box, is going to be 40 pounds. So what would be the weight of the small box? Well, we recognize that the total weight is 55 pounds. So subtracting 40, we get 15 pounds. And that gets the job done.